Welcome to the Explainer. We're always trying to break down the big ideas, and today we've got a really interesting one. It's a new concept that could totally flip the script on how AI actually remembers things.
All right, let's just jump right in with a wild thought. What if you could get an AI to read an entire book, not by feeding it word by word, but just by showing it a picture of the book? Yeah, it sounds a little like sci-fi, I know, but this idea is actually getting right at one of the biggest hurdles that AI developers are facing right now.
So the problem is what we're calling the AI memory bottleneck. You've heard all about these massive large language models, right? Well, they've got a pretty serious memory issue. The moment you try to give them a really long document, they just kind of choke. They really struggle, and their whole ability to process all that information just hits a wall.
And there's a really specific technical reason for this. It all comes down to something called quadratic scaling. Now, that sounds complicated, but here's the simple version. If you double the amount of text you give an AI, the work it has to do doesn't just double, it quadruples. And you can imagine this makes trying to process something huge, like a whole book, or even just a long chat history, insanely slow and super expensive.
So how have we been dealing with this? Well, the old way is to basically top up all the text into these tiny little pieces called tokens. You can think of them like pieces of words almost, and you feed them into the model one at a time. But like we just talked about, the more these tokens you have, the more that computational cost just skyrockets.
This is where some researchers at DeepSeek-AI stepped in and asked a pretty radical question. They said, okay, what if we just stop thinking about text tokens altogether? What if we start thinking visually? So instead of feeding the AI all those little word pieces, what if we just showed it a picture of the page?
And that question brings us to this brand new idea, optical compression. The whole concept is this. You take a ton of text, turn it into a single image, and then let an AI that's good with vision read that image. See, a single picture can be represented with way fewer visual tokens than all the text tokens it would have taken otherwise. And that could be the key to smashing right through that memory bottleneck.
Okay, so to actually prove that this could work, the team went ahead and built a brand new model just for this task. They're calling it DeepSeek-OCR, and it was really designed from the ground up to be the test case, the proof that this vision-first way of handling text is actually possible.
So, how does it work? Well, it's got two main parts. First up is the DeepEncoder. You can think of this as the AI's eyes. It's a really powerful vision system that looks at the page, figures out what's on it, and then compresses all that visual info. Then you have the second part, a language decoder. And its job is to take that compressed visual data and basically translate it all back into the original words.
Now, the way this DeepEncoder works is actually pretty clever. It doesn't just try to swallow the whole page in one gulp. Nope. First, it scans the image in these small, manageable chunks, almost like reading with a magnifying glass, to get all the tiny details. Then, and this is the key part, it shrinks all that visual data way down. And only then does it kind of step back and look at the compressed, big-picture view to really understand the context. It's a super smart way to handle a massive amount of detail without getting bogged down.
All right, so the theory sounds great, right? But the real question is, does it actually work in practice? Let's get into the results, because this is where things get really interesting. So the researchers put the model to the test at a few different compression ratios. First, let's look at a 10-to-1 ratio. Now, what that means is that the original text had 10 times more of those text tokens than the visual tokens the AI was using to see the image, a huge reduction.
And the result? I mean, this is incredible. The model managed to reconstruct the original text with over 97% accuracy. It could basically just look at that super compressed image and read the text back almost perfectly. That is a huge win.
But, they didn't stop there. They decided to really push it. So what happens when you crank that compression way up, all the way to 20-to-1? We're talking about cramming a ton more information into that same visual space. Well, even at this totally extreme level, the models still held on to about 60% accuracy. And, that might sound like a drop, but it's not a failure at all. What this shows is a graceful degradation. The information doesn't just disappear into thin air, it just fades. Kind of like how our own long-term memories get a little fuzzy over time.
And check this out, this really shows just how efficient this thing is. On a standard test, another really powerful model needed almost 7,000 visual tokens just to process one page.
DeepSeek-OCR, it got even better results using fewer than 800. That is a massive, nearly 90% drop in the computational heavy lifting.
So look, this is about way more than just having a better way to scan documents. The real game changer here, the big takeaway, is what this means for AI memory. We're talking about a completely new way for AIs to process and remember huge amounts of information.
And the researchers themselves are already thinking about what's next. Just imagine, you're having a really long chat with an AI. Normally, it would eventually just forget the beginning of the conversation, but with this, it could just compress the older parts of the chat into these little visual memories. That way, it keeps all the context, but without running out of its active memory.
This really creates a totally different way of thinking about memory. You see, the old way has this hard limit. After a certain point, old info is just gone. Poof! But with optical compression, your context could theoretically be unlimited. The old stuff just fades away gracefully. It gets less detailed, sure, but it's never completely lost.
And what's really cool is this could let an AI do something that feels very human. It could simulate forgetting. So, recent stuff. That gets stored as a super high-res, crystal-clear image. But as that info gets older and less relevant, the AI could just downsize the image, making it a little blurrier, a little less detailed. It's a perfect mirror for how our own memories of things that happened long ago start to lose their sharp edges.
And the key thing to get here is that this forgetting isn't a mistake or a bug. It's actually a feature. It's a really smart, really efficient way for an AI to deal with a potentially endless stream of information. It can decide what's important enough to keep in high def and what can just fade into the background.
And all of this leaves us with one last, pretty fascinating thought. This whole dive into optical compression. It's not just about making AI faster or more powerful. By giving it a memory that can fade, that can degrade gracefully over time, well, we might just be making it a little bit more human.